Oops. Wow. Ah, magnifique. Okay, so it looks great. Okay, so it looks great. Yep. All right. In this exercise, explore automated machine learning and Azure machine learning. In this exercise, explore the automated machine learning capability in Azure Machine Learning Studio and use it to train and evaluate a machine learning model. Exercise and follow the instructions. You can sign up for an Azure subscription which includes free credit for the first 30 days. I don't have a subscription, I believe. Oh my god, I do. So, Internet of Things, manage identity and access, security of data and cloud infrastructure. Okay. Migrate infrastructure app. So these are all the things. Skip. I'm gonna skip. Now let's show you around. Quickly create a resource or just view the... Oh my god, that's amazing. Or just view the wide variety of service in the Azure Marketplace. View key info quickly, top Azure services, common tasks, viewer customizable. Dashboard that displays exactly what you want. Resources, service, alerts, tutorials, and more. Kubernetes, we saw that. That's interesting. SQL database and quickly find resources you're looking for. Natural language. Get help. Nice, okay. That's amazing. So now if we go to... oh my god, I left the... Alright, so in this exercise explore the automated learning capability and use it to train and evaluate a machine learning model. If you don't... Alright, so create an Azure machine learning workspace, sign into the Azure portal, select create a resource, search for machine learning, and create a new Azure machine learning resource with the following settings. So create a resource, should be somewhere around here. Oh, computer vision, that's cool actually. I might want to use that not for this, but for this. Okay. Create a new Azure Azure machine learning. Okay, so that's what I want. Create a select a resource group. First of all, I'm gonna do that. A resource group. So all resources are built together. Are built. Hold on. I VD. Oops. Alright, so Concordia Azure. That's insane. I mean, sure. Alright. Model to predict knowledge check. You want to create a model to predict the cost of heating an office building based on its size in square feet and the number of employees. This is a regression. It's about numbers, basically. Are you to evaluate a classification model? Which metric can you use? Not this. Not this. Oh shit, I kind of forgot. I think it's the classification uses like sigmoids to pick between options. Now, mean squared error, that's not the correct, that's for regression, I believe. No. Oh man, I genuinely, I forgot. I'm not gonna lie. Precision silhouette. I don't know what that means. I don't think it's that. Okay. Maybe mean squared error. That wouldn't make too much sense. I'd say precision. Alright. In deep learning, what is the purpose of a loss function? To evaluate the accurate difference between predicted and actual label values. Yes. How does automated machine learning? So the loss function aggregates differences between predicted and actual label values. What does automated machine learning in Azure machine learning enables you to do? Automatically Azure train, automatically provision Azure machine learning workspaces for new data scientists in an organization, automatically run multiple training jobs using different algorithms and parameters to find the best model. I think it's that. Wow, I got it right. It was indeed precision. Mean squared value was for the regression type. Summary: machine learning is the foundation on which artificial intelligence is built. In this module, you've learned about some of the core principles and concepts on which machine learning is based and about the different kinds of model you can train and evaluate. The module also introduced Azure machine learning and cloud platform for end-to-end machine learning operations and gave you the opportunity to use automated machine learning and Azure machine learning for yourself. Great. Keep up the great work. Fundamentals. And I've earned an achievement. Now I can do cloud services types, fundamental AI concepts, which is about 36 minutes. Work with compute targets and machine learning. I think I've done enough. I want to see what this is. If I go on my student account here for Azure, Azure student, I don't even know where to go, to be honest. Azure, if I go here and I connect on my student account, okay, so if I go here and I connect, I don't even know where to go. Bro. Let me just go here. Actually, let me go here. Student hub. Maybe it's not here. I don't even know. If I go my CU account, if I go apps and software. Mathematica. Oh, that's cool. Efficient, high quality charts. Okay, but no, I'm here. Now, what do I want to do? I want to see, visit the Microsoft login page. Okay. Alright. Alright. Node.js app. Let me go. No. Engineers develop. Okay. That's horrible. Horrible. That's kind of cool. These three are kind of cool. Alright, let me go learning. That's so cool though. What? PyTorch. Fundamentals. I feel like I need to learn this. I feel like I need to learn this. There's so much. I know PyTorch and TensorFlow are pretty important. Good for data scientists and developers. Um, I have a basic concept. I want to create machine learning models. I want to see this. There's so much I have to go over. So much. Now, let me, you know what? Let me do a lead code first, and then we'll just go do one of those, or do both of those. I don't know, but I want to do that. Then I want to do this. There's this whole list of, of things. Then I have to do what this. Alright, so let me go this one. So you're given two not okay no frick linked list. I'm gonna lie. So I'm given two sorted arrays, nums 1 and num2 of size m and n respectively. Alright, return the median of the two sorted arrays. The overall runtime complexity should be 0 or big O log m plus n. I don't know how to do time complexity. Oh, this is hard. Oh, never mind. I don't like integer manipulation. Very well, string to integer. This is actually really, well, not really easy, but it's not bad. Just turn it into a string and then you concatenate it and then okay, so I to S, I think it's, no. What is it? Is it just that? Ah, no, it's this. To string X, then we're gonna say string, I don't know if I can use that actually, but okay, let's just call it that. And then string equal this. I want to run it just to see if it has a problem. Oh, it doesn't have it. What if I try to something like that? It's not gonna work. Oh no, I didn't. Oh my god. Okay. Oh, I'm so done. Oh, I'm so done. First of all, it was this, not to str. I don't know why I did that. Second of all, it was to string, not to str. Okay. All right. So we have this. Now we're gonna straight up just say switch num string 0. Then we're gonna say case is equal this, and then case is no, then default. So this is going to be, bro. Okay, so this will be for when integer is negative, and then when integer is not negative. Okay, nice, perfect. So alright, there we go. So now if it's negative, we'll just add the negation at the end. What we're going to say is I thought, what could we say? Hold on, I'm trying to think here. It's on 120 and then this is 21. Okay, I want to test something here. I want to do something. First, I want to try to return 021. Okay. Actually, yeah, let's return that. And I want to see if it returns 32. Excuse me. That's why. Oh, so, no, that's, oops. Okay. Please tell me. Okay, no, it doesn't. Alright. Let me see. That took a bit too long. Yeah, oh, no. That does not. What does it return 26? It's so odd. Attends. With 0. Okay, octal. That's why. I knew there was something like that. Octal meaning that this would be 16 plus. No, that's not true. Octal binary is what? 1, 2. This is 2 plus 3 times 8. 3 times 8 is going to be 68. So 16, 24 plus 2, 26. Yeah. Unfortunately, this is... so you can't really do that. Okay, I see. It's kind of a bit tricky. It's a bit tricky. You can't just do that. Now, for this, we'll go step by step. So basically, we need to look through the number. And I think the best way to go about it is to concatenate is as you look through. What if I make it a vector of characters? Would be not very efficient. I'm trying to... If reversing x causes the value to be outside the sign 32-bit integer range. Okay, so return 0. Now, what if when integer is not negative? So here you just do that. Here you would, but there was a way. I know I can do it, but I want to think a bit more. So if you loop here, now what if you? Oh, okay. Hold on. You just start. Okay, so for Okay. String reverse. It's not going to be very memory efficient, but it is what it is. Okay. So we're going to have that. And then for int I, int I is equal to 0. Non-string dot length minus 1. As long as I is bigger than 0, bigger or equal than 0, I minus minus. Okay. Now, what we're gonna do is we're going to loop from end of number to beginning. Okay. Now, there's a better way to do this. Would there be a better way to do this? No, I don't think so. No. Alright, so reverse, I know there probably is, but reverse string plus equal num-string plus equal num-string I. However, we're just going to check first if the character is the negation sign, because if it's the negation sign, we're not gonna basically reverse it. We're just gonna make there won't be actually a negation sign because we already checked for that. Sorry. So okay, plus equal this, and then okay. I'm trying to think how we can remove the 0, or maybe no. So if I do standard des, okay, so I'm guessing if I do that and I say return standard des that's not gonna work. 0 to 8, it's not gonna work. Okay, or at least I doubt it's going to work. I hope it will, but valid digit 8, but I don't want it to be la, da, da, if I do this, I'm experimenting a little bit, I'm not gonna lie. Okay, but that's not okay, Tom, what if I do this to string this and then dot, okay, that's actually it's not gonna work because bro, come on, please. Actually, it's not even gonna work, period. Okay, it doesn't work, doesn't blah. Alright, so after all of this, once this loop is done, if reversed string actually I have a better idea. So we're basically going to loop through reverse string, and then I forgot what the term is, but we're basically just gonna cut the string, and we'll take the substring. Okay, just count me on this. So it's very non-efficient because you're looping and looping and looping, but it's fine. Sj equal reverse string dot length -1. Sorry, no, it's equal to 0. As long as j is less than reversed string dot length j plus plus, and then we're basically going to what? I don't like this. Let me do that. Okay, so there we go. Now if, hold on. Okay, yeah, it starts at the beginning. So if reversed string dot of j is equal 0. I don't know if I should do that. Is equal to 0. Is not equal to 0. Sorry. You're gonna wanna want to break out of the for loop, because you don't need to do it anymore. And then you're gonna wanna return, or basically say reversed string is equal reversed string dot substring C++. I always forget, but okay. Do substring dot sub str. Oh, okay, so I got it right. And then we say j, and then reversed string, and this is the length, so you want dot length minus j. Alright, so this is what you want. Okay, so we do this, and then we break, and then we return reversed string dot length, this, and then here, this is for the negation. We copy, it's exactly the same stuff. Ah shit, attends. So if that's that, then that means this will end up here. So this will, shit. Yes, this will end up here. Okay. So it's actually the exact same stuff. So do this, except when we do the substring, we do minus j minus 1, because you want to remove the negation part, and then you ah shit. And then you add thought, and then you add. I thought, and then you add. Is not equal to 0 and or is not equal to and is not equal is not equal. Attends. So here it's or. So when it finds here, it's not equal to that, not equal to this, and not equal to that. Okay. Minus, and then we're going to here add, so what if it's gonna add concatenating a character to a string because it's weird, and then s to I, and then I do this. This is very poorly efficient. Oops. There we go. And then, so I got the right answer. I didn't get the right answer. Two milliseconds, that's kind of a lot actually. It's because I take the wrong, no I don't. So what if instead I do this, I take out this condition, no, it's not gonna work. Oh my god, it is. Alright. Now, let's make another test case. What if it's minus 120, so it's gonna be minus 0, blah. Alright, let me try that. Okay, we got it. The thing is only out of range. Okay, that was what I was expecting, in the sense that because here they say you cannot, because let's go outside of the 32-bit integer range. What is 2 to the power of 31 minus 1? 2 to the power of 31 minus 1. It's 204. No, it's 2,147,483,000. So it's 2 billion something, right? In that case, it wasn't 2 billion. Is it? It's 1,534,000. Whatever. Okay. S to I, given a 32-bit integer. Assume the environment does not allow you to store a 64-bit integer, signed or unsigned. So we're kind of cooked. What is a try-catch C++? You know what? I'm actually gonna try it. I don't even know. I never tried it. I want to test it out. Let me see. So let me do boom and then catch. I doubt it's gonna work. I doubt. Nope. Yep. Okay, for some reason. Weird syntax, but okay. What do you mean it expected a type? Okay, what if I tried this? Int x is equal this. Call if returning an instance of out of range. STD out of range. Okay, so it still doesn't work. That's odd. It's really odd. Let me go into further details for the S to I. What if now Hmm. Hmm.
Doing my homework and I want to talk.
So how can I do this? S to I out of range. Alright, so because it says here you cannot store 64-bit signed or unsigned. Now long, yeah, it's 64-bit, so I can't use that. Oh, that's actually practical. Unsigned integer. So 8-bit, 64-bit. 8-bit. Okay. So that would be pretty dumb, but let's try to do that. Let's try to say, nah, it's not gonna work. Is it? Yeah, it's not gonna work. Nah, it's not gonna work. Is it? I wonder. Heartbreak is one thing, my ego's another. Let me see if I can improve the resolution maybe a little bit. I have to capture the output and whatever. Never mind. Right. Let me go. So this won't work. What if I make my own? So I go ahead and make a int string to drop camel case and Pascal case. This I use for variables. So functions, I think I want to use this. String to integer. And it's going to take in a string num. And alright, so what is it going to do? Is it's going to... oh my god, this is so bad. I just know it's so bad. But you never know, okay? So switch and then num 0. Oops. Alright, so case, again, we're gonna check if negative. and then default actually. Heartbreak is one thing, my ego is another. Alright, so we have these again. Now, what we're gonna do is we're gonna loop through the thing. I have a very clear idea. Hold on. So let's say the size is 3, that means it's 10 to the power of 3. No, it's 10 to the power of 2. Yeah, okay, so we're gonna have an int decimal power equal well, yeah, actually just that's it. And then we're gonna say des pow is equal to this num dot length minus 1. So 210. Yeah, okay. So it's that, and then here it's going to be the exact same thing, except it's actually going to be minus 2 because you want to take this out of consideration, whatever. All right. So we do this. Then what we're gonna do is for int I is equal to 0, as long as I is less than shit. As long as it's less than or no, not again. So here's what we're gonna do. We're gonna do it should be super easy. Let's start at 0, it's going through the length. This part is equal to this. Yeah, actually, that's it, actually. Alright, so num dot length minus 1. Actually, just num dot length. So it's going to loop through the whole thing. And then here we're going to say I plus plus des pow minus minus 2, because you can have more than one in for loop. I don't even know how they're called. So two changing in for loop in C++. So I do 2 increment statements. Okay, I got it right. Alright, so that's cool. And then what we're going to do is for each number we're going to, and then actually I'm going to do both at the same time so that I don't get lost here. It's going to loop through the start. Actually, we're going to make it from here, and then minus 1. Sorry, no, that. And then we're going to say this, and then same code, same code. So we're going to say num I, well, actually int converted int, okay, num I, sorry, converted int plus equal num I multiplied by des power, decimal power, and then here we're going to say s to I. Okay, so here that should make it whatever. Okay, so we're gonna do that, and this, and then at the end we're gonna return converted int. Okay, because this is negative, we're gonna also say this. Okay, and then here I do the same. I don't need a break, I'm returning anyway. negative. And then here we're going to, okay, this is useless. So I basically implemented my own function, and I'm going to say return string to int of this. Let's run that. Is there a... Oh, you can just cast it for this? Okay, that's cool. String to int, I guess, is a bit more complex than just straight up this. So we do this. I feel like this is not gonna work at all. We do that. Yeah, okay, because it basically converts the character into its character value or whatever. So card to int. I want this done. Minus thoughts. What? No way that works. Num plus equal this minus this. This could work. It does make a little bit of sense. Minus 0 is basically an integer value. It does kind of make a little bit of sense. I want to see if it does actually work. Not at all. 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 Alright, that doesn't work. Or maybe it's just that this is not good. So let me see out. Sorry, let me see out num I. I just want to see what it looks like. Okay. Three, two, one. Oh no, so it is good. Okay, but thing is, yeah, because I can use strings, but like in terms of memory, I wouldn't like that too much. I guess static cast. That is what we saw in class. Now static cast destination type and the source. Let me try this. So let me try cout static cast integer of num1. Let me try that. Okay. Oh. And not num1, num I, I'm sorry. Heartbreak is one thing, my ego's another. See, it does this. Now, if I'm being a rat, actually I can just manually do that, right? It'd be dumb, but I guess that's just the way you go about it, right? So you do this, and then you do num I. Let me just see what is equal to what. Not num1, num I. Retard. Alright. So 51 is 3. Boom, 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 boom. So it's minus 48. Let me just do that. I'll do it manually, and then, yeah, I'll just do it manually. Minus... Ah, okay, I get it. Yeah. I get it, man. I get it. Get why they do that. Minus 48. Hey, that's not dumb, because it's... Yeah. This is the first one. Blah, blah, blah. So you just do that. Alright, so that's not retarded. Now, minus 48. Would that work? Also, let me just do this, because there's a multiplication right after. If not, I know what the problem is again, and I'll have to basically cast it into an int, and then minus 48 it. Yeah, so we're going to do static cast int num minus 48, and then this. What? Why? I didn't get it, man. Let me try to... I don't get it. Bruh. I know I'm dumb. I'm really dumb, actually. Times the decimal power. What am I doing? Chat. It's times 10 to the power of the decimal power. Hello? So this is actually num I minus 0 times 10 to the decimal power that you want. Alright, so this is what was missing to the piece. Well, actually, I'm just going to copy this whole line. And let me see. This should yield the correct result. Not quite. Not quite. Now let me try this. I shouldn't take this long, to be honest, but also it's probably going to be pretty bad. Maybe not. Let's hope not. Alright, so this 3, 2, 1. Let me do times 10 to the power of 3. Let me try that. Hmm. That makes no sense. Oh my god. Okay, focus. So, dear fellow scholars, I could make a power. Yeah. I really don't like this way of doing it, but because I cannot use 64 or whatever. Um, let's make my own. So, int power raise. Okay, let's call it that. So, int power raise. Okay, let's call it that. So we're gonna have this, and it's gonna take into consideration a des power, obviously. Des power. I don't even know if that's the right term. I don't care. And then it's gonna do for int I is equal to 0, as long as I is less than, so 0, 1, 2. Yeah, okay. So as long as I is less than 0, then that's pow I plus plus, and basically all it's going to do is it's going to say 10. Wait, hold on. So int raised int is equal to 1, and then it's going to say 1 times 10. So no, raised int times equal 10. So then shit, hold on. If decimal power is, let's pretend decimal power is 0, right? It's just gonna stay at 1. If it's 1, it's gonna do that. Okay, because it's less than 0. No, sorry. If that is 0 and I is 0, 0 is not less than 0. Okay, so that we're good. And then we're gonna say return raised int. All right. So we made our own function. Now what we're gonna do is we're gonna multiply by the power raise of despow. Now this should work. Dun 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 dun. Oops. Okay. There we go. Did you mean power raise? Yes. Sorry. I have to get used to my naming conventions. Alright, so we have this. Okay. Let's try 168. Because this is a 16. I don't even know. Okay, what if I do this? I do try this, catch, return 0. Exceptions. No, that's not how it works. Ah, scheiße. Okay, so this is still gonna crash though. First of all, let me see if it works. Let me see if I delete this test case and I run it. This is far from working. I don't get it. std cout. And I'm just gonna do this. Okay, I'm gonna do end line. I want to know what is wrong. Okay. I'm guessing it's this. Something along those lines. Yeah. Okay, that was dumb of me of doing that, first of all. Second of all, yeah, that was dumb of me. Let me go to runtime error. Oh, this is zero mess. This is even faster because I made my own, right? They're very well adapted for this. Now let me create my own test case, this time with this. Now, I don't know how I'm going to test for long hints and whatnot. Undefined behavior solution. Runtime error signed integer overflow. Cannot be represented 9 times. Okay, what's an integer? Okay, attends. Given a signed 32-bit integer, return x with its digits reversed. Go outside the signed integer ranged. 2 to the power of 31 minus 1. So it's 2 to the power of 31 minus 1. Let me actually just do that. Okay, 2 to the power of 31 is this. Right? So it's the dra. Wait, but wouldn't, like, I don't get it, chats. Cannot be represented in type int. What cannot be? Signed integer overflow 9 times. Is that 1 billion? That's 1 billion. 9 times 1 billion cannot be. Why did you even ever do 1 billion times 9? Because I never asked you to. That's for sure. That is for sure. I never asked it to do 9 times 9 billion. 9 times 1 billion, sorry. So why did it do that? It goes from this, and as long as it's less than that. So why did it do that? Why did it do that? Why did it do that? Now it's gonna be 9. Sorry, it's gonna be. No, it's not gonna be 9. I'm struggling to find the. because obviously this is the limit, right? The limit is going to be 2,147,483,648. So, okay, let me just do signed int limit. Okay, so why the hell is this giving me an error, a runtime error? Because this is clearly less than the signed integer value, right? It's clearly less than this. Actually, use test case. There we go. So why is it doing that? It's positive. Ah, I see. I'm dumb because we reverse it, so it then becomes 9 billion. So if the decimal power, okay, I have another thing. So if the decimal power is equal to, so what is it? 1 billion? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it's 9 and greater than 2, oh, but that's not, huh? It's difficult, man. It's really difficult. So now we're just taking if it's over 1 billion, if it's over 2 billion, but it could be 2 billion point 2, and that would also crash. So wouldn't you have to check the limit? This is becoming oh my god, this is becoming difficult. Cannot be okay. So if avoid crash, two test cases. So if it's true, is a bigger or equal than 0? If it's true, alright, so I guess I'll make another function. Bool over int limit. Okay. and it's gonna take in a string number, well, reversed number. Sorry, num. Now, it's gonna have to check for this now. Minus 2 to the power of 31. So int signed int range. Again, we're gonna have to do a case. So switch reversed num 0. This is insanely complicated for no reason, I feel like. But anyways, so we're gonna do this, and then we're gonna say key, default actually. Default break. There we go. Now, one thing I'm going to do for this is basically iterate over. So okay, for num force car num in, actually I don't know if it's, I think you cannot do that. I'll try it, but I think it's not gonna work. Reversed num. Sorry, no, I don't even need to do a for loop. Oh my god. Okay, I just need to check it. Alright, so in the case that is here, first of all, we're going to say if reversed num dot length is less than how much is it? It's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Less than 11. Then just return false. Okay, that's it. Otherwise, we'll have to do some stuff. Here it's going to be 10, I believe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, so here we're going to say if it's less than 10, return false. It's not over the limit. However, if it's equal to that, we're going to say if it's going to be a super long if loop, okay? If reversed num addition or loop through. I can try both, but yeah, okay, let's just try both. For I want to use an array. So string, hold on, so string, sorry, array C++. I don't know why, I forget. Okay, string, int positive limit equal, and it's going to be an array of 10 numbers. Limit equals de 1 4 7 4 8, donc de 1 4 oops de 1 4 7 2 1 4 7 4 8 2 1 4 7 4 8 3 6 4 7 3 6 4 7, and then we're going to say for int I is equal to 0. Let's just use a for loop like this, and then say if I is less than reversed num dot length I plus plus, and then here we're going to check. So we're going to say oops, sorry. So boom. Okay. Here we're gonna try to catch it and say over limit is true. Otherwise, return false. Okay. All right. So first is going to check for this. Wait, if it's under or equal, under or equal, under or equal, under or equal, under or equal. This is very complicated. It shouldn't be that complicated. Should it? Going on. Alright. Okay, so automatically we're in the billions. If it's bigger than this. So, no, you know what? I'm going to say this. So I'm going to say if int, no, Oh man, I don't know. Positive 0 is bigger. Wait, that's so tough though. How am I supposed to check? Am I supposed to check from the last or the first? If that is bigger, no, if it's less than this, return this. Ah, okay, I get it. My god, that took way too long to conceptualize this. Okay, so you loop through. If okay, let me not stick to this. Basically, all right. If oops. Okay, so you're gonna loop from the first. You're gonna say if it's bigger, return. Okay, so if reversed num I is bigger than int positive limit I, you're gonna want to return it's over the limit. Otherwise, I mean, return false. It's not over the limit. After it's gone through all the stuff, right? Yeah. So otherwise, I mean, return this. Cool. Now we're gonna do the exact same stuff, but for this, here, actually it's gonna work even for the negative 21474883648, because it's gonna, the character is gonna get returned into a int value. That int value is not gonna be bigger than if it's the same. You know what I mean? So we don't need to do that. Ah, but that's unfortunate because so this is the switch case, whatever, whatever, and then here we have our actual stuff. If all right, so we have that. We have this now, string in positive limit, blah blah blah. If reverse.num is less than 10, then automatically return it's not over. If then otherwise you're gonna go through this whole stuff. If it ever goes over the positive limit, well, the int limit actually, now that I think about it, it's going to return true, so it is over the limit, and then otherwise return false. And then here, before we sorry, where do we do it? So when we create the reversed string, right? So first we check that. So is it called that? I forgot. Over int limit. What is it? It's like ternary operator. If that is true, good day. Good evening. So now what I'm gonna say is this. I'm gonna make the condition. So over int limit of reversed string. I'm going to say return revert string to int reversed string, and then return 0. Something like that, right? I don't know. Probably gonna be an error somewhere. Yeah, unfortunately we can't have the return, right? And then we're gonna say return output int. Love me better than I could buy myself flowers. Write my name in the sand. Talk to myself for hours. So let me check that. Things you don't understand. All right. not over int limit. Uh, so if return false, and also if no, it doesn't work. That logic doesn't work. That logic doesn't work. Oh my god. If it's smaller than the int limit, okay, so let's say it's 2. If it's 2, so if the reversed num is 2, sorry, no, I'm confused here. Let's make a sample, okay? I just want to practice. So let's say it's 2, 1, 2, 3, blah, blah. Okay? So is the reverse int number bigger than this? No. Continue. Bigger than this? No. Bigger than this? Yes. Return true. Let's say it was this. This? No. Bigger than 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 this? No. If it's bigger or equal to the int limit, so if it's if okay, no, that doesn't work. Okay, let's do let me show you how I come through with the 1-2 shit like kung fu. But then still, why did that not work though? Because let me do C out. Oops. Let me do what the heck? Let me do C out. I'm going to say reversed num, which is the value we're kind of interested in. Reversed num. And then I'm gonna copy this actually. Okay. Call it int limit. Limit. Alright, and then we're gonna put it here. Actually, we're gonna remove this. Reverse num 3, 2, 1. Oh, that's a big problem. Actually, no, why? I already made the test case. If reverse the length is less than 10, return false. I made a mistake. If it's over the int limit true, then it's over the int limit, return 0. So that's okay. Made a slight mistake here, which I'm going to fix. There we go. Alright, so now this works. Int limit, blah blah blah. This will not work. This logic is flawed, and I know it, but I will still test it out. I will try this test case, even though I know it's not going to work. It will work for this particular case. However, if I do, let's say I changed it, right? So let's say here I made it not 2, I made it 1. Oops. Can I not modify it? Hello? Oh, okay, let's see. Test cases. Let's make another one. This one, we're gonna make it be 1. So that's 1, 6. And you'll see, and let's make another one where it's going to be 2. So you'll see that this one will work, the other one won't. Because this logic is flawed. Straight up. Voila. There we go. It doesn't work. The best way I see, or the best way I can go about it is make nested if loops or something. No, that would be really dumb. Okay, I thought so. All right, if also let me try negative. So let me copy this, and let me try this. This should work as well. Yes. Yes, it worked. Okay. Now for this, this is the problem I'm running into in the over int limit, is that it's checking for each. It's checking if reverse num is over that limit. Okay, no, so first we have to check if reversed num I is, because it starts at the biggest, right? So is less than the limit. Oh no. Less or equal the limit. So, okay, so that was, okay, I get it. I less or, so if this is less or equal the limit, keep going. Then if this is less or equal to the limit, keep going. Oh, but this is not. Oh no, sorry. Less than the limit. Okay, now I got it. I got the logic wrong, basically. So if it's less than the limit, just straight up return return false. It's not over. Okay? Now, if that happens to be the case, this will be this will not return false. It will just continue going over this. Now this, oh, still equal, so it will not return false. It will just continue going. Oh, okay. it would loop through and just say, no, the second it's less, automatically it's going to return false. Otherwise, it's going to return true. Okay, so this is what I had to do, sorry. Never mind. If it's less than the int limit, return false. Like what? Why does that not work, chat? So that means alright, so oh no, because then here it's less. If okay, I get it. So if it's less or equal. This is so stupid. Like, why am I struggling so much for such an easy check? Okay, if so as it loops, maybe there's no way of doing this, or maybe I'm just dumb. If that is, so first it checks, is this bigger? Okay, no. Okay, just automatically, first of all, if that is bigger than the int limit, he told me he built a time machine like one in the film I'd seen. Yeah. He said I've been to the year 3000. Okay, there's something bugging here. There is something bugging. Not bugging, but I don't like the idea of not doing a for loop. Not much has changed, but they lived underwater. Your great 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 granddaughter. Okay, now I think the only special case is when it's equal. Because when it's over, you know, when it's under, you know. When they're equal, you have to check the one under, right? So if it's so when it's equal, and your great 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 granddaughter is doing fine, doing fine, doing fine. Alright, so if those are equal, check the following. If those are equal, check the following. If those are equal, check the following. Okay, if those are equal, continue. So basically, if those are equal, continue to the next. If those are equal, continue to the next. Then, then when they're not equal, it's gonna be able to go through the second if condition. That is, if reversed num I is over int limit I, return over true, so it's over. Otherwise, return false. I feel like now I might have gotten it. Dang it, I don't. Alright, so for the case of this, I want to know why that didn't work. Int limit is equal this. Alright, so is this equal to this? No, therefore continue. Is this over this? Okay, so let me try this. Maybe it's just a I'm having a big brain poop issue, okay? Having a big brain poop issue. Alright, so one. Okay, let's simulate this. Beep, I equals 0. So 2 and 1. Alright. This is reversed int. If reversed int is equal to this, that's not the case. If reversed int is less than this, return false. It's not over the limit. So why didn't that return false? I don't get it. That should have automatically returned false. If so why So for this, length has to be 1, no, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then for this, what the hell? Okay, so it's 10. So it should not return false here. Let me just see out through. It went through that condition. All right, now test. Oh my god, oh my god. Okay. Now we got it. It should work. I don't know. Oh my, how can I forget this? Basic stuff. And we don't got it. Okay, so reverse num is equal to this. So for this loop, 9 is equal this. No. If reverse num return false. Could that be? It's gonna crash because it doesn't return a value all the time. Yeah. If it's equal, continue. If it's over, do this. If it's that, do that. Automatically do this. Now it's 3 milliseconds. That's pretty long. it's pretty long. I'm not gonna lie. Pretty disappointed with this, but we have a power raise function, we have over int limit, we have a reversed string. Yeah, we're not good. We are not good. Yeah, my my thing is not good at all. Well, that's that. Okay, let's do PyTorch fundamentals. Okay, maybe not this. Not yet. I don't want to go there yet. Speech, vision, and natural language. Voter tech resilience. Alright, so sandbox activated, time remaining 1 hour 59 minutes. This is one of 10 sandboxes for today. More sandboxes will be available tomorrow. Import os.environment, qdev visible devices equal -1. Import TensorFlow as TF. Import gzip. Import numpy as np. Now, do we have Python installed? I didn't even check. Yeah, we do. Let's open Visual Studio Code, because we're going to need it. And let's... This is special. It's special, but I like this better. Alright. Let's make a new... me better there. TensorFlow learning. Learn TensorFlow. And we're going to open a folder. Learn TensorFlow. Okay. Alright, so we have that. Now, time remaining 1 hour 57 minutes. You have used one. Okay. If the kernel doesn't always select when you run the code, choose from the drop-down menu. You might get an error, but no. GPU or CUDA capable device was found. However, the code should still run successfully using CPU resources. Right, so import library. Let's start by getting familiar with the data you'll be using. The Fashion MNIST dataset. This dataset contains 70,000 grayscale images of clothing. Grayscale images of articles of clothing. 60,000 images for training and 10,000 for testing. The images are square, so we're going to have some ones that have known labels and then 10,000 that don't have known labels, which are used for testing because, well, you want... Actually, I don't even know. 10,000 for testing. Testing what? The images are square and contain 28 times 28. They all have labels, actually. Sorry for that, but... Alright, so the images are square and contain 28 by 28 equals 784 pixels, where each pixel is represented by a value between 0 and 255 because it's grayscale, so it's 0 to 255 white for all red, green, blue channels. Each of these images is associated with a label, which is an integer between 0 and 9. Alright, so this would this qualify as a regression or would this qualify as a classification? I believe it's classification, and then it gives a probability of each integer of the array, of the map. Actually, it's a map. Okay. Each of these images is associated with a label which is an integer between 0 and 9 that classifies the article of clothing. The following dictionary helps us, so it's a dictionary, helps us understand the clothing categories corresponding to these integer labels. Alright, so 0 is a t-shirt, 1 is trouser, whatever. If you're following this code but executing it outside of the Microsoft Learn Sandbox notebook environment, you can load Fashion MNIST by calling the load data method of the Fashion MNIST dataset in the Keras API. As you can see in the commented out code below, Keras provides an easy way to get not only Fashion MNIST but many other popular datasets through tf tensorflow.keras.datasets. This Learn Sandbox notebook already has the data locally, so you can load it directly instead and create 4 NumPy arrays containing the training and dataset, the training and test data and labels. So here TensorFlow as tf, okay, NumPy probably. Okay, so this, just do that, I don't want. Let me do this. Alright, let me go, so training, images, def, so it's a function, read images, path, this, image size int, num items, this is what, this is numpy, yeah, and the array with gzip.openpath.rb as file, from buffer file read int offset 16, data equal data.reshape, num items, item size, oh, that's actually pretty cool. See real world examples. Okay, but anyway. Def read labels. So here we're reading the images, which are basically the features, I think is what it's called. and then we read the labels. So with gzip.openPath rbs file from buffer file read num items plus 8 offset 8 data as type blah blah blah. So image size equal 28. So 28. Oh, it's Python. I have to get used to it, sorry. Alright, so image size, oops. It's gonna be an int. Num items, number of items int. And data array. So numpy, I guess it's the whatever, read images. Path of the image. Image size, so in pixels, 28 by 28. Then we say the number of items. So number train, 60,000, and then test 10,000, right? And then return data, which is what? It's a, is it a data type? Data type? What does it mean this? But I'm guessing it's a data type. And then data.reshape. What would that mean? Num items. I guess gzip is just a way of better opening stuff. And then read labels. So training images equal read images from this gzip, okay. From this librarian, image size num train. Test images is gonna be the same. And test labels is going to be this and then this. So this will be used to test, and then this will be used to train. Now that you have the data, you can display. So this is where you don't want to overfeed, for example. Now that you have the data, you can display a sampling of images and corresponding labels from the training data. You can display a sampling of images and corresponding labels from the training data. So import random matplotlib pyplot as plt. That's a convention. And then figure equal plt.figure. Figure size is 8 by 8. Would that work? Kernel launching. It's pretty slow. This is Python 3.8, so it's Azure Microsoft Learn Python 38, well 3.8. Doesn't seem to want to run. It's looking like it will run. Okay, so what would that do? So fig size 8 by 8, column 3, row 3. I don't know what that means. For range 1, 9 plus 1, so 10. From 1 to 10. Sample IDX. I'm having a hard time figuring out what that is. So for image equal training images sample index. So sample index equal random sample index. Okay, so you're just gonna take a random sample index between the 0 and the length of the training images array. Read images is gonna return. So this is an array kind of. Okay. I see. Then image.squeeze cmap equal gray, plt.show. Alright, let's inspect the first label in the training data. As you saw in the labels map dictionary that you printed earlier, this corresponds to an ankle boot. Okay. So as you saw, this corresponds to an ankle boot. Now let's inspect an image that corresponds to this label. So the training images, an image is composed of, and then training images. Ah, so now it works. Okay. Great. So sample index. It's really low, but okay, so that's good. Telling me, alright, image equal blah 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 blah, image.squeeze, plt.show. Now let's inspect the first label in the training data. So training labels 9. So as you saw, okay, image that corresponds to this label. I see. 8-bit integer. Unsigned integer 8-bit. An image is composed of pixel values, and each pixel in the image is of type unsigned int and contains a value between 0 and 255. For such a small data set, you could just use the NumPy arrays given by Keras to train the neural network. However, if you had a large data set, you would need to wrap it in a tf.data.dataset instance, which handles large data better by making it easy to keep just a portion of it in memory. You can wrap your data in a dataset in this sample, so you're prepared to work with large data in the future. Train dataset equal tf.data.dataset from tensor slices, training images, training labels. This is very complicated. You saw earlier that each pixel of the image is represented by unsigned int. In machine learning, you generally want the pixel value of your training data to be floating point numbers between 0 and 1. So you convert them in the following way. Train dataset equal train dataset.map. Yeah, because it can otherwise very easily go into voila. So you convert them in the following way. Map lambda image. Why all of this? Label float image divided by 255 label. I don't know what that means. You might have noticed that each value returned by the dataset is a tuple containing an image and a label. You divide each value in the image by 255. Oh, okay, I'm dumb. Yeah, that's gonna normalize it. And keep the label as is. To see the difference, inspect the value of the same image that you inspected earlier. Alright. As expected, the pixel values are now floating point numbers between 0 and 1. Now that you have a dataset, you can no longer index it the same way as NumPy array. Instead, you get an iterator by calling the asNumPy iterator method and advance it by calling its next method. At this point, you have a tuple containing an image. What is a Python tuple already? I think it's like it's a collection data or set, list, and dictionary, all with different qualities. It's a collection which is ordered and unchangeable. Okay. Alright. So method. At this point, you have a tuple containing an image and the corresponding label. Equal float 32 t-type. Where's the label though? I don't know. Now that you have a data set, you can no longer index it the same. Okay, I already read that. Finally, tell the data set to give. Okay, at this point you have a tuple containing an image and the corresponding label, so you can get the element at index 0 to inspect the image. Finally, tell the data set to give us batches of data of size 64 and shuffle the data. Batch size equals 64, train dataset dot batch size dot shuffle 500 times. So it's gonna shuffle the data so that it's random. Is that so? Test dataset equal test blah blah blah. Dataset that when you iterate over it, you want to receive not one but a batch of 64 items instead. If you print the length of the first item returned by the iterator, you can see that you get 64. Now, why do you want to get batches of 64 when iterating over the dataset? We'll come back to that in the section on training. First, you need to learn about the neural network architecture that you'll use for this sample. So we're using a neural network. Check your knowledge. Why do we encapsulate our data in a dataset? We didn't need to for a small amount of data like this in the sample. We could have just used NumPy. It's a good idea to learn about it, especially if we're going to work with larger data in the future. Because it returns our data in batches of 64 images when we iterate over it, which we use later when training. So it's all of the above. Alright. So that's why we use dataset instead of, I already forgot. Hold on, let me go back. I can't go back. I can. Okay, so we did that. Wait, but that's... Alright. Oh man, 1 hour 40 minutes remaining. Alright, so import OS blah blah blah. Your goal is to classify an input image into one of the 10 classes of clothing. So you define your neural network to take as input of a matrix of shape 28 by 28. So here it was one dimensional. Well, it's just a list of those. And because it's an image, you'd want this. That's so bizarre. Okay, you'd put a matrix of 28 by 28, which basically is representing each pixel of the image, and output a vector of size 10, which is gonna tell the probability for each, where the index of the largest value in the output corresponds to the integer label for the class of clothing in the image. Where the index of the largest value in the output corresponds to the integer label for the class of clothing in the image. For example, if you use an image of an ankle boot as input, you might get an output vector y like this. And this is much larger, so in this particular example, the largest value appears at index 9, counting from 0, as you saw in the previous module. Index 9 corresponds to the ankle boot category, so this indicates that your neural network correctly classified the image of an ankle boot. Here's a visualization of the structure of the neural network you chose for this scenario. And this is a 28 by 28 matrix. Because each image has 28 by 28 equals 784 pixels, we need 784 nodes in the input layer. Okay, so that's exactly like we saw in this introduction. And here we saw that, for example, when you had 8 parameters, you needed to place a vector, not a matrix, a vector, but a vector is a matrix, a one-dimensional matrix of size n, and each of those had to call for all the other neurons in the next layer. And I think this is just their way of saying it, that basically these connect to the rest, and then these connect to the rest, and then these connect to the rest, and it goes from left to right, and it ends up into a it ends up going, so this is a classification type of machine learning stuff. It's a classification. It's not regression. It's not giving me a value, integer value for some such stuff. It's not, and I think classification is one of the nicer things. Though I saw the uncategorized classification, that's actually also pretty interesting. It uses a very clever technique that uses vectors as well. But yeah, never mind that, because each image has 28 by 28, well, 700. Okay, you want to output okay, here's the Keras code that defines this neural network. So class neural net, so you create a class neural network, and it's a Keras model, and then super, I don't know what that means, neural network self in it. So this is the constructor. Then self.sequence equal tf Keras sequential, Keras layer flatten, input shape is 28 by 28. So you're telling basically that the shape of the input is going to be 28 by 28 matrix. It could have been 28.1, but now we're saying 28 by 28. Keras layer is dense. I don't know what that means. 20 activation value, and then dense 10. I don't know what these define. Oh, okay, it's explained here. So, because, okay, we need 784 nodes in the input layer, one for each pixel value. Add one hidden layer with 20 nodes. Okay, so here's 784. Then we have a dense, so it's gonna compact it, I'm guessing. ReLU, I don't know what that means, and then it's gonna densify it as 10. Add one hidden layer with 20 nodes, and a ReLU, rectified linear unit, activation function. You want the output of your network to be a vector of size 10. Therefore, your output layer needs to have 10 nodes. So here's the Keras code that defines this neural network. So I don't know what made us want to have a ReLU, rectified linear unit. But basically what it did is layer flatten. So it basically, we're telling it that we have an input shape of 28 by 28, and it's gonna give 784 input nodes. Well, an input layer of 784 nodes, sorry. And then we're telling it to densify it. I'm guessing this is just a predefined stuff in the Keras library that is a rectified linear unit. It's just a mathematical thing. And then flatten, so okay, and then it's gonna say create a new layer, Keras.layers, dense 20, activation equal, so this is the activation function, and we want the activation function to be a rectified linear unit. I don't know why, but that's what we want. Maybe we're going to learn about it later. So we tell it ReLU activation is what we want, and then we want to redensify it into 10. So this is the neural network, and it's just telling it we want 10 different things, and it's basically just automatically going to, because of the data of the training, it's automatically going to assign to the 10 different stuff. Yeah, and then def call, I don't know what that is. Oh, that's the to test the recall. No, I don't know, maybe I'm wrong. Def call is a function of the class neural network. So let's say we create a neural network T. T.call is gonna take a tensor. I don't know what that means. Y prime equal self.sequence x. I don't know. Alright, so the flattened layer turns your input matrix. Oh shit, I gotta hurry up, dog. Okay. The flattened layer turns your input matrix of 28 by 28 into a vector of size 784. Okay, flatten is this. So flatten is into one dimensional. Okay, that kind of makes sense. Turns your input matrix of shape 28 by 28 into a vector of size 784. The dense layers are also known as fully connected or linear layers because they connect all nodes from the previous layer with each of their own nodes. With each of their nodes. Each of their nodes connect to all nodes from the previous layer. So this is basically what we saw in the introduction to machine learning earlier. The dense. Notice that they specify ReLU as the activation. That's because you want the result of the linear mathematical operation to get passed as input. So you want the results of the linear mathematical operation. The result of this linear mathematical operation to get passed as input to a rectified linear unit function. This will add non-linearity to the calculations. So rectified linear unit adds non-linearity. So maybe a sigmoid function, or could it be? It's probably a sigmoid function because you want it to be between 0 and 1. So I'm guessing that. Okay, and it's going to densify it into 20 and then 10 again. It's important to have nonlinear activation functions like the ReLU function between linear layers, because otherwise a sequence of linear layers would be mathematically equivalent to just one layer. Oh, that's interesting. I'm guessing it's because mathematically linearity is okay, so you have to separate them by non-linear functions to basically go out. Okay, would be mathematically equivalent to just one layer. Oh yeah, because you could linearity, I mean, they just add up and then it's just another linear function, so there's nothing. These activation functions give our network more expressive power, allowing it to approximate non-linear relationships between data. The sequential class combines all the other the sequential class combines all the other layers. Where is the okay, sequence self.sequence. So the sequence equal tf dot, so you're initializing this neural network class into a Keras model, I believe. That's what I'm getting at here. Then you're setting the sequence of this model, of this neural network model, as the Keras sequential. Now the sequential class combines all the other layers. Last you define the call method which supplies a tensor x. The call method which supplies a tensor x as input to the sequence of layers. And produces the y prime vector as a result. Also, this is just to call the call the model, and then you give it a tensor from the TensorFlow library, and then it basically y prime equals self dot sequence, so it's going through the sequence of layers with this tensor, and it's gonna return you the y prime, which is a vector of 10 stuff. That's crazy. Okay, I kind of get it, but I at the same time I don't. You can print a description of your model using the summary method. So model equal neural network. Simple enough. You just create this class, an instance of that class. Then you build it. I don't know why you would build. Call a function build, but okay. So you say build, and then you create one. 28 by 28 input shape, but wouldn't that be defined here? I don't know why you would dot flatten input shape equal 28 by 28. So you want to flatten it, right? I'm not sure I understand why we do this, but okay. And then model that summary. So neural network, layer type, sequential, output shape 10, and then parameter 15,910. Trainable parameters 15,910, non-trainable parameters 0. This is all the code you need to define your neural network. Now that you have a neural network and some data, it's time to train the neural network using that data. What's the output of the neural network used in this sample? A vector of size 10 where the largest floating point number is in index 9, which corresponds to an ankle boot. That's correct. Alright, so sandbox activated, sorry. Time remaining 1 hour and 26 minutes. You have used, okay. So now that you understand how to get the data and model, you're ready to train the neural network. So we set up the data. And we were able to visualize it using NumPy. Using Matplotlib. Now that you understand how to get the data and model, you're ready to train the neural network. First, you need to load the data using the technique discussed in the first unit in order not to cluster this notebook. Now that you understand how to get the data and model, you're ready to train the neural network. Not to clutter this notebook, we've added the getData function and neural network class you've already seen to separate control.py file, which you import here. So what happens during training, you need to add a little more detail to our neural network visualization. And there's bias. Bias just comes out of nowhere and you just add it to the... Alright, so in order to understand what happens during training, you need to add a little more. So there's a lot of information in this diagram, so let's expand on each of the new concepts here. Notice that you've added weights to the connections between layers and bias as input to dense layers. W and B are the neural network's parameters. Your goal when training your network, also known as fitting, is to find the parameter W and B that minimize the difference between the actual and predicted labels for your data. Notice also that we added a loss function to the diagram. This function takes in the outputs of the model Y prime, the predicted models, and the actual labels Y, measures their difference, and combines those into a single output, which we call the loss. The loss provides and it's the aggregate of the absolute differences. The loss provides a single number that quantifies how similar your predictions are to the actual labels. Yes, a high loss indicates that they're different, and a low loss indicates that your predictions are accurate. The loss function most frequently used in classification. So when you have a classification model, the loss function you want to use is cross entropy loss. And Keras provides several varieties of this loss because your dataset includes a single integer label for each example. Use the sparse categorical cross entropy loss function. So it's a cross entropy loss function to determine how much you've lost, how accurate is your stuff. And then I don't know, because your data set includes a single integer label. Okay. So for in this case, this is what you want to use. Okay, so we're having a classification model, and the labels of the data is just a single integer label. Either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we want to use this, a sparse categorical cross entropy loss function. Now let's look at what happens in the dense layers. Dense layers add a linear operation involving when they added nonlinear, add a linear operation involving the input data and parameters W and B. For example, the top node of the first, so for dense layers add a linear operation involving the input data and parameters W and B. For example, the top node of the first dense layer performs the following calculations. This is the top node, Z11, equal the weights multiplied by the input 1 plus all the way up to the input 784, the node 784, plus the bias. The bias, I mean, like T-Soding said, even for me, I don't really know what it does, but it just helps, okay? So we'll just keep that. There is a bias, and it's a linear equation. Dense layers add a linear operation involving the input data and parameters W and B. For example, the top node of the first dense layer performs the following calculation. If you specify a real U activation function, the output of the linear operation is then passed as input to rectifying linear unit. So A11, so this is the answer of Z11. A11 is what happens to Z11 when you pass it through a rectifying linear unit. I think it's that's the name, but real U. Mathematically speaking, you can now think of our neural network as a function L that takes as input the data X, expected label Y, and parameters W and B, then perform as a function L that takes as input the data X, expected labels Y, and parameters W and B, then performs a sequence of operation on that data and returns a loss. So loss is equal that function. No. So that's actually our neural network. It's actually the loss. And it's just a function that takes the data, expected labels, the parameters Y, W, and B, right? And so for the specific data and for those specific labels, we find those specific weights and bias. Well, we actually iterate, and then we find those. And then when you lock it into a specific function, boom, that's our model. And then you can inference it. Your goal is to find the parameters W and B that lead to the lowest possible loss. So the X and Y generally stays the same. You can't change our data X or the corresponding labels Y. Okay, so that's because they're fixed. But you can adjust W and B. I mean, the data, it has to stay the same, the labels same. It turns out that the problem of this can fall into the well-studied mathematical area of optimization. So these are a long series of equations, and then you have to solve for the optimization. Simplest minimization algorithm is gradient descent, and this sample uses a variation known as stochastic gradient descent, or SGD. The training process is roughly as follows. What is it? It's sparse categorical for the loss function of a classification with integers as labels, single integer labels. You would use a sparse categorical cross entropy loss function. Okay. The training process is roughly as follows. First, the parameters W and B are initialized to random values. You then make predictions using those values and evaluate the loss function to measure the quality of the predictions. And last, use the optimizer to adjust the values of W and B such that... Wait, I didn't even read. Okay. First, the parameters W and B are initialized to random values. Okay, so that's what we saw with T-Soding, right? So W and B are initialized to just random values. You then make predictions using those values. So do that with this. And then evaluate the loss function to measure the quality of the predictions. Now chances are, because it's a random like random weights and random, this is a vector, right? Yeah, I don't know why though there is, for there's one thing I don't know why is why there is 1784 weights. Huh. I don't know why, but okay. So this is stochastic gradient descent, or SGD. The training process is roughly as follows. For the parameter W and B are initialized to random values. You then make predictions using those values and evaluate the loss function to measure the quality of the predictions. And last, use the optimizer, so you have an optimizer function, to adjust the values of W of the weights and B, and the bias, such that the loss will be a bit lower next time. Repeat this process until you found parameters that give a very small loss value and good predictions. You're now ready to compile the model. This is where you tell it that you want to use the SGD optimizer and the sparse categorical cross entropy loss function. You also tell the model that you want to report on the accuracy during training. Deserve a quick explanation. Man, this is going by so fast. Alright. Look at above, deserve a quick explanation. So here we're going to say train get data batch size model. We create the model loss function equal dot losses, and then you want to use to calculate the loss. You want to use the sparse categorical cross entropy function. So sparse categorical cross entropy from log it's equal true. I don't know why that, but okay. Then you want to optimize, so look for better B and so a better bias and better weights dot, and you want to use stochastic gradient descent. So this is the simplest minimization algorithm, so I have to memorize it. So optimizer equal tia.cures.optimizer.sgd learning rate, and it takes the learning rate. So basically this will be the increment. If it's small, it's gonna learn but pretty slow. If it's big, it can learn but pretty bad. Okay, there's something with that. Okay, metrics equal accuracy model that compile. So then you compile the model, you optimize it, you calculate the loss, you calculate the metrics. Notice that you pass from logits equal true to the loss function. This is because the categorical cross entropy function requires a probability distribution as input, meaning that the numbers should be between 0 and 1, and they should add up to 1. Your network produces a vector of numbers that have no upper or lower bound called logits. So you need to normalize them to get a probability distribution. This is typically done using the softmax function and specifying from logits equal true automatically calculate softmax before computing the loss. Notice that you pass a learning rate to the SGD optimizer. The learning rate is a parameter needed in the gradient descent algorithm. You could have left it at the default, which is 0.01, but it's important to know how to specify it because different learning rates can lead to very different prediction accuracies. Finally, notice that we specified a batch size which you use in the construction of the dataset. As you saw earlier, this is important during training because it tells the model that you want to train on 64 images at a time. You might be wondering why 64? Why not train on a single image at a time or all 60,000 images at once? Doing a complete training step for each individual image would be inefficient because you would have to perform all the calculations 60,000 times in order to account for every input image. If you included all the input images in X, you need a lot of memory and you'd spend a lot of time computing each training step. So we settle for a size in between called the mini batch. Now that you've configured our model with the parameters you need for training, you can call fit to train the model. You can call fit to train the model. Specify the number of epochs as 5, so you want 5 generations. And then model.fit epochs equal epochs train dataset. No, okay. Training has found values for the parameters W and B such that when you provide an image as input, you get a reasonable prediction as output. One is not ready to be tested. Remember that when you loaded the data, you obtained 2 datasets, one with training data and another with test data. It's time to use a test dataset that evaluating accuracy 84%, loss 0.438. That with each generation it gets. Okay, so you've achieved pretty good test accuracy considering that you use such a simple network and only 5 epochs of training. You're done with training and can now save the model. So model.save outputs.model. After these generations, you see it's pretty good, blah blah blah. So you just in the code say .save and then you put the what do you put? You put the repository in which you want to store it. What's the goal of training a model? The goal is to make it faster, is to find parameters W and B that lead to the best prediction. Loss function. Each of the input example. No, so find parameters, blah blah. Okay. So making a prediction. That is not 10 minutes, chat. Alright. So, making a prediction. Assuming you achieve pretty good accuracy during the training and testing phase, you can now use the trained model for inference. In other words, the model should predict the classification of images that the network has never seen before. But before you move on, load the code you've already seen in previous notebooks. Remember that in the previous notebook, after successfully training our network, you saved the model. Let's load it back into memory. So model tf.keras.models.load model. Intro keras intro.py, whatever. So already I could make some sort of Within the previous notebook, after successfully training our network, save the model. Let's load it back. Making a prediction is easy. Simply call the model's predict method and pass one or more images. Let's start by getting the image you'll use for prediction and display it. Image.open requests.get URL stream equal true.raw as image. NumPy. Is it NumPy? Yeah, NumPy. It's just a better array. A much better array. This is the image you want to load. Plot.figure, and this is just to display it to us. So PLT, so my pyplotlim, matplotlib. X equal numpy dot as array 28 by 28. Figure axis off, cmap equal gray, x dot squeeze. I don't know what that means. As you can see, you have an image of an ankle boot in the code below. Load the image call predict to get its class index and map that index to the class name. Okay, so predicted vector is going to be equal model.predict x. So you're going to get a vector in prediction. Predicted index equal numpy dot the maximum argument of the predicted vector. Maximum value along an axis. Okay, so straightforward so far. And then the predicted name is equal labels dot, and then you call the dictionary. So predicted index. Okay, the maximum argument of the predicted vector, you get the predicted index, and then you get the predicted name, which is from the dictionary, the predicted index. And then you're gonna print predicted class, boom. But you can also get probabilities of the input image being of a certain class, in which case you need to normalize the output of your network using softmax to get probabilities. Here are the predictions for your image. Yeah, to get probabilities, you need to normalize it using softmax. So probs equal tf, so tensorflow dot whatever that is, and n. Okay, dot softmax. Predicted vector dot reshape. For I, p in enumerate probs, print labels map. I, whatever that means, but it's basically going to normalize the float to 3 decimals. And then you see that you have t-shirts, trousers. So these are 0%. There's a 0.174% probability of it being sandals, 0.050% of it being sneaker, 4 like various low percent, and then 77% chance of it being ankle boots. If you need to compute probabilities, often you can check activation equals softmax for the final dense layer of your network. Also, that's why. So if you want to prioritize this, in this case, network would give you probabilities as output, and you need to omit use logics equal true in the sparse categorical cross entropy loss function. What kind of images can we use as input in the prediction in the format expected by the model? It has to be 28 by 28 because we have 784 nodes. Thank you so much for sticking with this learning module until the end. You learned a lot, and now you have the basic. Thank you so much for sticking with this learning module until the end. You learned a lot, and now you have the basic tools to make predictions using your own data. You have the basic tools to make predictions using your own data. You learned how to prepare your data, how to define your neural network, how to train and test it, and finally how to make a prediction using your trained network. In this notebook, we bring together the most important parts of the code you saw throughout this module, so you can easily refer to it in the future. Thank you. So I'm just going to do basically just going to copy this. Reference.py. Okay. How can I add it to my environment? Let's say I want to run. Start debugging. You don't have an extension for debugging. Find Python extension for sure. Alright. Let's just do that. All right. All right. Nice. Okay. Now we can debug it. It's probably going to tell me that we don't have a module named numpy. We don't have blah blah blah. So we're going to say pip version. Oh my god, we have that. That's insane. Okay, numpy. Really? How come we have no module name? Would you like to create a virtual environment with these packages to isolate your dependencies? Because I installed Python packages into my global environment. Yeah. So I want to create a virtual environment with these packages to isolate my dependencies. Yeah. Let's do that. So set the Python installation to create the virtual environment. Environment. I think maybe now it's gonna work. I don't know. We'll see. Environment. I think maybe now it's gonna work. I don't know. We'll see. All right. Let's do that. So now what if I do this? Ah, okay, hold on. Environment. Where do I change it? Kill terminal. I don't know, to be honest. Hold on. I don't know. Terminal. I don't know. Where do we do that? Where do we do that? Um. Hmm. Let me check. Hold on. Pip. Let me see. Pip list. Guess we don't. Why does it say we do? Oh, no, it says we don't. That's odd, okay? TensorFlow. Oh my god, this one is big. That's a big ass library, chat. Okay. It's still not gonna work, but it's good thing to have, right? So let me go here, projects. I go this. Pull this out. Do 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 do. Um. What could I make? Something that's very simple. I could use audio maybe instead of this. No. Um, Image is good. I gotta go pee. This shit is big. Why is it working? Okay. Uh. Oh wait, what am I? Pip install. Keep pillow. Okay, so now would that work? If I do this? It wouldn't. Yeah, it wouldn't. Alright, so pip list. Pip uninstall. I want to uninstall everything, okay? Because this is pretty bad. Yeah, so there they are. Okay, virtual environment. Okay. So now I can keep working here with this environment and have a... That's just great. Honestly, it's just great. Important parts of the code you saw throughout this module, so you can easily refer to it in the future. With TensorFlow. Infrastructure as a service, platform as a service, software as a service, identify appropriate use cases for each cloud. So I need to learn all of this. Then I need to so we did this. Then I need to, what could I do? Really? Concordia. Ideally, I'd rather have. Hold on, let me go. student center. What do you mean? Oh my god. Also, let me see my class schedule. Okay, let me see actually. Let me do that. Okay, new class schedule builder. Course sequence software MIAE winter flip-flop entry. So MI and stewardship. Can I take something with oh, that's annoying, but it is what it is. Alright, so search this for this. So it's engineering and natural science group, software engineering. Yes, MIAE 221. MIAE 221. Alright, we have that. And who's the teacher? Sam. Okay, let me search this on Google. Alright, okay. Alright, so that's very good actually. Let me check. So this is MIAE. Alright. So COM 249 233. So N228. So N287. MIAE 221. Okay, MIAE 221. j'étais vraiment bon alors que les autres ont coulé. Si j'étais bon. Si j'étais bon. So I have no reason to believe I cannot do it. And I have to take it anyway, so might as well, right? I removed the stewardship and whatever, which is in my summer. And these will be easy, and then this. And I have this. Alright. MIAE. Wait, what? No. Wait, what? No, 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 no. Bro, is it that hard to make a schedule? Also, why does that stop all the time? Okay, alright. So we have engineering 233. We have 228, so N. So N 287, column 249, and MIAE 221. MIAE 221, engineering, okay, whatever. And so now we have this, which is, we start at 12, we start at 4, we end at 10. But, yes. Alright, so now let me go to, actually, or maybe actually more swap classes. Continue. Stewardship with MIAE 221. Engineering 233. Bro, are you retarded? Yes. Do actions. That's how I do enrollment. Swap classes. I'm gonna select this and swap it with this. Okay. There is no way. Oh my god. I got myself into a waitlist chat. This year I never get into the lectures. I'm telling you right now. I think we're gonna call it a day here. Tomorrow we're gonna do a bit more of those, of this, of this. Tomorrow we'll do this. Oh, why did I swap? I hate. But then again, this is less bad. Actually, no, this is really bad. Oh my god, I'm so dumb. I was just. Oh my god, bro. No, this is actually insane. Oh yes, let's go. And then let me guess, she has a good rating. Maybe it's not the same. Maybe it's not the same. Oh. I have MIE, but I don't have engineering. Yes, let's go. Well, technically I have all 5 classes, it's just that it's horrible schedule. And that, oh my god, why did I flip? Anyways, we're gonna call it a day, chat. Good night.